All right, let's begin. Hello, everyone. Thank you so much for joining the 30th session of STEM Quest 3.0. Today, we have a truly inspiring guest, someone who will light up your day and give you information in ways I've seen few people do, to be honest, whether it's about mental health, medical school applications, neuroscience research, cooking, really anything. And that is Mia Soviero, who is a graduate of Barnard College at Columbia University in New York. And she is now preparing for medical school. She has done a lot of research in neuroscience, and her bachelor's degree was also in neuroscience and pre-medical studies. She's also the founder of a global nonprofit organization empowering student leaders in STEM globally called Research Girl, who is also a key partner of Youth STEM Initiative. So make sure to check out Research Girl as well. Mia, it's a great pleasure to have you here today. Take it away whenever you're ready. So the floor is yours.
Thank you so much. Thank you for having me. I've been really fortunate to work with Youth STEM Initiative a little bit over the last year or so. Has it been a year already? Almost a year. Through Research Girl and also through other avenues. So I'm really excited to present today. Today, I'm going to be presenting about something that I'm really, really passionate about, which is the neuroscience behind trauma memories. So today's lecture is The Brain Behind the Behavior, Neural Correlates of Traumatic Memories. So who am I and why do I study trauma? My name is Mia Soviero, and I'm a neuroscience researcher. I previously worked on mental health studies at Columbia and NYU, and I focused on autobiographical memory and how memory relates to mental illness, whether that's depression, anxiety, or my favorite topic, PTSD. Why am I so invested in trauma? Trauma is very personal to me. I have lived with trauma, PTSD and CPTSD since I was 5 years old. So it's a very personal topic to me. I have lived experience where I can relate to the patients that I'm interacting with in studies. And so it's, very personal to me, and it greatly influenced my decision to pursue neuroscience in the first place, because my early experiences of experiencing PTSD and wondering why my brain was the way it was were part of what got me into neuroscience. So many of you here probably are not diagnosed with PTSD. However, something that I think we can all relate to is what's called an intrusive memory, which shares some qualities with PTSD and is different in some ways. So I want to ask, have you ever had a memory pop up when you didn't want it to? I think we can all probably say that the answer is yes. Maybe you were trying to fall asleep and you remembered something embarrassing that happened to you once, and then suddenly you couldn't fall asleep because you were thinking about how embarrassing that thing was. Or maybe you were trying to take exactly at 3 a.m., staring at the ceiling, thinking about this embarrassing moment in your life. Or maybe you're taking a test and you're trying to focus on taking the test, but you're hungry and you're thinking about what you ate for lunch yesterday. And all you can think about is how much you would rather be eating this delicious lunch than taking this test. Those are examples of intrusive memories. And these are pretty benign intrusive memories that we all experience that are not pathological, that is different or not normal. So we all experience these things. But these memories share a quality with PTSD, which is that they are intrusive, involuntary. And I'm going to talk a little bit more about what that means in just a second. So first, let's start at the very beginning. What is trauma? Trauma occurs when something overwhelms the brain's ability to cope. I think there's a common misconception that trauma is defined as how severe something was, how bad an experience was. I think a lot of people think, oh, you have to have experienced this or this or this, or in this specific way in order for it to be considered trauma. That is not correct. Trauma is defined by the brain's response. Two people can have experienced the exact same event, and just their brain will deal with it differently. So one person could experience it as trauma and develop PTSD or develop a different trauma disorder because of that event. And the other person could just go on with their lives and be able to process that event because their brain just responded to it differently. All of our brains are different, and that is why trauma is not defined by the severity of an event, but rather how your particular brain responds to it. Another key fact within this vein is that not everyone who experiences trauma will develop PTSD or CPTSD. So some people will have a traumatic experience and it will be trauma to their brain, but they won't develop a trauma disorder from that. So everyone's brain is different. There are a lot of different trauma disorders, but today the one that I'm going to focus on is post-traumatic stress disorder, or PTSD. And you've probably heard of PTSD before. It's colloquially associated with veterans or traumatic events that happen, like car crashes. Maybe you have experienced PTSD because you watched someone pass away. These are classic examples of what we think of when we think of PTSD. But actually, you can experience PTSD and be diagnosed with PTSD from, like I said, any number of events. It isn't dependent on the severity of the event or a specific type of event that you may have experienced. Instead, PTSD is diagnosed based on you meeting criteria in 4 categories. So you experiencing symptoms in 4 categories, and these symptoms have to last for more than a month after the event. If you experience these symptoms within the month after the event, you could be diagnosed with acute stress disorder, which is essentially a precursor to PTSD. But if those symptoms continue past a month, then you can be diagnosed with PTSD instead of acute stress disorder. So what are these criteria that you have to meet? The first, criteria A, is exposure. So the person must have been directly or indirectly exposed to a traumatic event. You could have been in a car crash and actually experienced the car crash, or you could have just witnessed a car crash. So it could be a direct or indirect exposure. You don't necessarily have to be the victim of a traumatic experience in order for you to develop PTSD. The second criteria B, is intrusion. This is what we want to focus on when we're thinking about trauma memory, and the neuroscience behind trauma memory is intrusion, criteria B. This involves flashbacks, nightmares, or these distressing intrusive memories that are, this is the point that is shared between the intrusive memories that I mentioned before, like when you're trying to fall asleep and you think of something embarrassing that happened. This is what's shared between that and PTSD, is the character that they are intrusive, in other words, involuntary. And then criteria C is avoidance. This is avoiding reminders of the trauma. So maybe now that you have PTSD, or now that you've experienced this traumatic event, you have to avoid certain places that remind you of the event, or certain people, or you can't do certain things because they're triggers, they remind you of the event. And then the final criteria is criteria D, arousal and reactivity. Arousal relating to alertness. This is irritability, hypervigilance, and self-destructive behavior. So maybe a person is really jumpy all the time, or easily startled, or they're scared or anxious or angry frequently. This is all under the umbrella of arousal and reactivity, criteria D. So those are the criteria that diagnose you with PTSD. And like I said, you have to have experienced these 4 things, or a symptom in these 4 categories, for at least 1 month after the traumatic event to be eligible, essentially, for the diagnosis. So what does this look like in practice? What I just explained to you was PTSD as it is described in the DSM, the Diagnostic Manual for Psychiatric Illness. These criteria in the day-to-day life, if you maybe have a friend who has PTSD, it might look like this: panic attacks, being easily scared or startled, experiencing unexplained or sudden anger, so somebody who is quick to anger. It might look like not being able to do certain things or go certain places due to triggers, like I said, avoidance. And then this final bit is what's really important for trauma memory, which is dissociation, nightmares, and flashbacks. Specifically, what it would look like colloquially is experiencing memories as though they are happening in this moment. And I'll get into that in just a second. Before I get into that, I want to take a quick detour into the world of neuroscience. I want to start with at the very foundational, just to make sure we're all on the same page about the neuroscience that's required to understand the neuro of trauma memories specifically. And that is starting with a neuron. Can anybody tell me what a neuron is?
Even me.
Yes.
Neurons are the cells in the brain, in the really basic.
Yes, yes. The neuron is a basic cell in the brain that sends signals. It communicates in your brain. And we have billions of neurons. And the important point that I want to hit home here that you need to understand for trauma neuroscience is not all of this about, how the neuron is made up, what the different parts of a neuron are. However, I want you to know that they are a basic building block, and a neuron makes connections with other neurons that form neural networks. And then those neural networks form even more connections that form brain matter, white and gray brain matter. And the brain matter forms brain areas that all together form the brain as we know it, as we understand it. And there are 3 brain areas that we care about the most when it comes to trauma and memory and the neuroscience behind it. The first brain area that we really care about is the hippocampus. This is the brain's, you can think of it as the brain's Photos app. So when you want to remember something on your phone, you open your Photos app and you can scroll to, like, let's say 5 years ago, a family vacation, and you can look at the photos and be reminded of the family vacation that you went on. The hippocampus does this. It's our long-term memory storage. So it allows us to recall memories and pull a memory from our hippocampus and then remember it. In that way, it's a little similar, and a good analogy to use is the Photos app. The second brain area that we really care about is the amygdala. This is the brain's alarm. Evolutionarily, we needed to survive. So we developed the amygdala as an alarm system, a tripwire. And what would happen essentially is that when there was a threat that required that we take action to survive, the amygdala would alarm, and it would create emotions like fear, anger, and anxiety that allowed us to do things that we might not have been able to do typically, that would let us run or hide and be more likely to survive. So that is what the amygdala does. And the third important brain area that we care about when it comes to trauma neuroscience is the prefrontal cortex. This is the brain's CEO. It's responsible for all of the higher order thinking that goes on in the brain. For example, decision-making, reflecting on things, thinking critically about things, and taking lessons from things. It sort of takes the context that we have going on in the rest of the brain, our emotions, the memories from our hippocampus, and it can derive meaning from those things and reflect on them. So these are really important brain areas, and I'm going to talk a little bit more about them in the rest of the presentation. So memory typically uses those 3 brain areas in a way that is easy to quantify. So we have this diagram here, and I'm going to give you an example of a memory. Let's say that 3 years ago, I gave a presentation similar to the one that I'm doing right now. And I walked up on the stage and I started giving my presentation. And at first I remembered all of the things I was supposed to say and all of the content of the presentation. And so it went really, really well. And then towards the end of the presentation, maybe I forgot the content, or I got stage fright and I messed up. And then I felt embarrassed. This is how a memory usually works. The story I just told you is a story. It has a clear beginning, middle, and end. It moves chronologically and in a linear fashion, and there aren't these weird gaps in the memory. I didn't leave any key points out of the memory, and nothing was blurry. That's how a memory usually works. It's told as a story, and if you'll recall, I said that this happened 3 years ago. So I know that it happened in the past. Usually when we remember memories, we remember them as things that have already happened to us in the past. Typically, the amygdala will add emotion to that story that we know happened in the past. So for example, I'm remembering that memory of me giving that presentation, and I remember how I was embarrassed at the end because I messed up my presentation. The amygdala is what will add emotion to that memory. So maybe when I'm thinking about how I gave that presentation and how embarrassed I was, I'll feel a little bit of that embarrassment again when I'm remembering it. The key point here is that how memory usually works is that I will feel a little bit of embarrassment when I'm remembering the memory, but it won't be so much embarrassment that it overwhelms me and makes me unable to continue on with my day. Then the hippocampus will create context for that story. So maybe when I'm remembering that memory, the hippocampus will say, hey, As well as that specific memory, do you remember how for the whole week leading up to that presentation, you were practicing, you were really nervous, so you practiced and you gave that presentation to practice to all the people you knew, and you did really, really well? That will be the context. The hippocampus adds context because it has all of our long-term memories, so it can add even more details to a memory by surrounding it with context. And then finally, the prefrontal cortex helps us reflect on that memory. So maybe I'm taking all of this that I've already processed about this memory. I'm taking the memory itself of the presentation, I'm taking the embarrassment, and I'm taking the fact that I prepared really well for the presentation. And my prefrontal cortex will say, so a lesson you can learn from this experience and from this memory is that sometimes we prepare a lot and we feel really prepared and things still go wrong, and that's okay. And that's a higher order learning, higher order thinking reflection on the memory that is mediated by the prefrontal cortex. So all of this is how memory usually works. I'm about to tell you how all of that goes out the window when it comes to PTSD flashbacks. So an important point that is crucial when it comes to PTSD flashbacks and trauma memories is the difference between remembering something and reliving something. I just went over how memory usually works, which is remembering. It is usually past focused. So like I said, we know that it happened in the past when we're remembering it. It's voluntary. So we can choose to remember the memory, and we can also choose when to stop remembering the memory. We can say, I don't want to think about this memory anymore, and we can shift gears and think about something else. It's also narrative, like a story. So like I said, it had a clear beginning, middle, and end. It passed chronologically in a linear fashion, and there weren't gaps. And it's regulated, which means that even though I remembered the embarrassment and I felt a little bit of the embarrassment when I was thinking about the memory, it didn't overwhelm me. And I wasn't frozen by the fear or the embarrassment or whatever I felt. This is profoundly different from reliving. Reliving a memory is present feeling. It feels as though the thing you are remembering is currently happening to you again. It's also involuntary. So you can't choose, I would like to think about this right now. I would like to think about this memory. It jumps in on you. If you recall, we talked a little bit about intrusive memories and how maybe when you're falling asleep, you don't mean to think about this embarrassing thing that happened to you, but you do anyway. That's a quality of reliving, which is that it's involuntary. You also can't stop thinking about this memory when you want to. So maybe when you're reliving something, you think, I don't want to think about this anymore. This is freaking me out. It's distressing. It's not a happy memory. And you would like to stop thinking about it. But in reliving, you can't do so. You can't switch gears and stop thinking about it. It's also sensory. So you feel a visceral sensation. Maybe your heart is beating really fast. Your palms are sweaty. You're shaking. I'm going to talk a little more about this, but I'm just going to briefly mention that this is the biological part of reliving that is different from remembering. In remembering, you don't have this biological part that is happening, but in reliving, you do. And it's overwhelming. So when you are reliving compared to remembering, that emotion that you feel when you're remembering the memory takes you over. It's overwhelming, and you might not be able to continue with your tasks, lead a normal day. It overwhelms you. That's another key difference. Which brings me to flashbacks, which are both a symptom of PTSD and something you've probably heard about related to PTSD, and they're an example of reliving, not remembering. So flashbacks are not traditional remembering. Flashbacks can be described as all-encompassing intrusive memories of a traumatic event. So many patients with PTSD describe feeling like they're physically back in their trauma, and there's a sense of displacement in time. They actually feel as though they're mentally time traveling back to the time when the traumatic event happened to them, and they're reliving it again. This is key. They also experience visceral sensations of fear. So like I said, they might feel their heart racing, their palms might get sweaty, they might feel shaky. These are all these physical characteristics, biological characteristics that are different from typical memories. And finally, flashbacks are disjointed. They're nonlinear. When people have flashbacks, they might remember the end of the memory and then the beginning and then the middle. It might be all jumbled up. It doesn't follow in chronological order. There are gaps in the memory, and everything is sort of blurry. All of this is fundamentally different from how memory usually works. And this is a recent finding, relatively recent finding. I think 2023 was when the paper came out that really kind of shook the trauma memory world and said memories that are trauma memories are fundamentally different from regular memories. So remember how I said there's a biological aspect of these flashbacks, of these trauma memories. I'm going to jump very briefly, and hang in with me here. I'm going to jump very briefly into medicine and what happens in the body when someone is experiencing these flashbacks that can cause these biological symptoms that make flashbacks different from regular memories. And in order to do this, we need to know the physiology of flashbacks, which brings me to the HPA axis, the hypothalamic pituitary adrenal axis. It's a mouthful, but it can be broken down. So when you experience any stressful event that requires fight or flight, this could be you being chased by something. This could be you being stressed out for a presentation. It could be a life-altering traumatic event. When this happens, a whole sequence of dominoes gets knocked over in your body. And this is a very, very brief, condensed version of these dominoes. The first thing that will happen is that the hypothalamus in your brain will say, hey, there's something wrong. We need to go into fight or flight. It will activate the pituitary gland, which will release hormones to activate the adrenal gland, which then releases stress hormones like cortisol. And those stress hormones are part of what allow us to survive in these life-threatening occurrences where we might need to fight or flight. So this is what happens in the body when a traumatic thing happens to you, in that first time, when the traumatic event happens. The key point here, in terms of memories, is that when the traumatic event happens to you and the HPA axis, that whole series of dominoes that I explained, goes off in your brain and in your body, when that happens, your brain consolidates a memory in the hippocampus. It consolidates that memory into long-term storage, but that memory has a label attached to it. And that memory of the trauma has a label that says HPA axis. The HPA axis was activated when you were experiencing this memory. And what happens with traumatic memories that is different from regular memories is that then later, when you remember that memory, the traumatic memory, when your brain plucks it out of the hippocampus and recalls it for you to remember, that HPA axis label is still on there. And so what happens is when you remember the memory, the HPA axis gets reactivated because it has that label attached to it. And so when you remember the traumatic memory, the HPA axis dominoes all fall again and you go into fight or flight, which is why when people experience flashbacks, they will experience the physical symptoms of being in fight or flight as though the trauma is happening all over again. So that explains a little bit of the biology of what is happening. Like I said, all of this is very different from how normal, quote unquote, normal memories work. Right? It's fundamentally different. So scientists took all of this, neuroscientists, and they said, we'd like to study this. We'd like to see what exactly is going on in the brain that might be different between PTSD patients and non-PTSD patients. So they did brain imaging studies. Brain imaging studies are things like MRIs, CAT scans, PET scans, EEGs that can show us the brain. What is being activated, how the brain is working, what parts of the brain are working, and the volume of the brain. Whether parts of the brain might be different, might look different actually anatomically in people who have a certain condition or do not. And so I have read over the last 5 or 6 years, over 50 studies that have come out that are brain imaging studies that investigate these things, which we call neural correlates of PTSD. And these are the 3 top findings across studies. These are things that are more or less agreed upon right now in the studies that have come out. The first is the amygdala. They found that in people with PTSD, there was more activity in the amygdala than in non-PTSD control subjects. If you recall, I mentioned that the amygdala is the alarm system of the brain. It's the tripwire that goes off when there's a threat, and it activates things like fear, anxiety, and anger. What do you think would be the result of more activity in the amygdala in people with PTSD? What do you think that means? If the amygdala is the tripwire, what do you think it means if there's more activity in that? It means that the tripwire is being activated too much. So normally, like I said, the tripwire, that is the amygdala, only goes off when there's a real present threat, a danger that requires us to go into fight or flight and survive. In people with PTSD who have more activity in the amygdala, that tripwire is going off all the time, even when there's no present threat. So this could be the reason why people who have PTSD have these visceral sensations of fear, because the amygdala rules fear. It creates fear, and it's getting tripped all the time, even when there's no real stressor. So that could be why, and we found that in a lot of studies. The second thing that we found across these studies is about the hippocampus. We found that the hippocampus had a smaller volume. It essentially shrunk in participants with PTSD compared to participants who didn't have PTSD. Now, we know that the hippocampus is the long-term memory storage place in the brain. It rules how we remember and recall things. What do you think would be the effect of having a smaller hippocampus, so therefore having less manpower, less neurons that are dedicated to us remembering things the right way? Exactly, forgetting. Someone said forgetting in the chat. Excellent. So with a smaller hippocampus volume, we can see that things like, things like having this disjointed nonlinear progression of memories where the memories are getting all jumbled up and they're not in the right order can happen. We can see that there could be gaps in memory. We could see exactly, leads to altered memories, someone said. Exactly. So these memories, these flashbacks, might be essentially tampered with due to this smaller hippocampal volume. And then finally, the other main finding of this was the prefrontal cortex. They found that there was less activity in the prefrontal cortex of individuals with PTSD. Now, if you'll recall, the prefrontal cortex is the CEO of the brain. It decides how to reflect and process all of the other things like memories and like the fear created by the amygdala. So what do you think happens when the prefrontal cortex, the CEO of the brain, is sleeping on the job? The CEO of the brain is not doing as much work as it's supposed to do to process things or to reflect on things. What do we think that means in the context of trauma memories? It means that we're not able to process those traumatic memories and therefore move on. It's why people who have executive dysfunction, so people who have PTSD, who have been shown to have less activity in the prefrontal cortex, then are stuck. They're stuck in the traumatic memories. This could contribute to the way that traumatic memories are intrusive. We can't switch gears and start thinking of something else. We become stuck because the prefrontal cortex, that is that higher thinking, doesn't let us move on. It also means that we can't reflect on the traumatic memories in a way that is higher ordered thinking, where we are thinking about the trauma in a way that lets us move on emotionally from the trauma. So those things are not possible when it comes to PTSD and the prefrontal cortex less activity. So these are some of the main findings in brain imaging studies. Just to recap, the amygdala has more activity, which means increased fear response, which we've seen with trauma triggers and flashbacks. The hippocampus has shrunk, so memories feel like they're happening now. They also are not linearly recalled, so they're recalled kind of jumbled up. And the prefrontal cortex has less activity, which means that you can't accurately reflect on memories and process them and move on. We've also done behavioral and memory studies. Behavioral and memory studies are things like administering psychological questionnaires to individuals with PTSD to ask them about their feelings. Memory studies can include the autobiographical interview, which can ask you questions about your memory that can allow us to examine the number of details people are remembering, how vivid their memories are, and what they remember. So these are behavioral and memory studies. And again, I've read quite a few of these because that is my job. And the main three findings from across all of these studies were the following. Number one, less episodic specificity. What does episodic specificity mean? It's basically a fancy neuroscientific term for details remembered. So less episodic specificity means that you remember less details about a memory. So they found that in individuals with PTSD, they remembered less details, which is consistent with this idea that flashbacks are kind of blurry and there are gaps in them. They also found that trauma feelings are generalized in individuals with PTSD. This was a behavioral study. This was actually several behavioral studies. This means that the trauma memories and everything associated with the trauma starts to infect unrelated memories. And things that are not explicitly related to the trauma can become triggers because they become somehow related. The brain starts making connections between the trauma and unrelated things because it's trying, probably, this is a theory, probably trying to sort out the memory and make sense of it because traumatic memories are very confusing and disordered. So it's trying to make sense of the memory by making connections to it. And unfortunately, a result of this could be that, well, it is, that unrelated memories that are not explicitly related to trauma then become related to trauma. And the third and final finding of all of these studies was that individuals with PTSD are likely to think more negatively about the future. So not only have we seen this impact on trauma memories, the past, but also the trauma and the memories then start influencing how these individuals think about the future. So just to recap all of that, this is what we know. We know that traumatic memories are fundamentally different from non-traumatic memories. We've observed brain changes like in a hyperactive amygdala, a shrunk hippocampus, and a sleepy prefrontal cortex. We have done memory and behavioral studies where we've seen that there are gaps in memory in individuals with PTSD and less detail remembered in traumatic memory. We've seen that trauma begins to bleed into other memories. And we've seen that individuals with PTSD start to think negatively about the future. Feel free to add this in the chat or to just unmute yourself and say, but I wanted to ask, what thoughts come to mind? When you're thinking about all of this, this could be that you've noticed maybe we should look into this and this thing together and how they might relate. Or you could just say, I relate to this thing. What thoughts come to mind? Any thoughts come to mind based on what we already know? Because I'm going to get into what we're looking to find out soon in just a second. Okay, I see some questions. These are good questions to think about. And wait, how do I get the chat, the whole chat? Here we go. Okay, sorry, forgive me. I am not a techie person. Okay, someone said, does having PTSD during youth lead to dementia later on? That's a question. That's a research question right there that's related to PTSD. Neurodegeneration, yeah, that's similar to PTSD and dementia. That could be a question. That's actually something that I am not familiar with because my specialty is not neurodegeneration. So that's a really good question to think about. I'm going to go into right now the theories that we have. So this was what we know already. Now I'm going to briefly get into what researchers are doing right now, the main leading theories in trauma memory. So there are three current theories that I'm going to go over today. There are so many theories out there, but I'm just going to go over these three because they're the most interesting to me and I'm the lecturer, so I chose them. So based on what we know, the first theory that I'd like to discuss today is the theory that hippocampal shrinking could be due to chronic HPA activation and cortisol. So remember how we found in the brain imaging studies that the hippocampus is shrunk in individuals with PTSD. And remember also how I said that the HPA axis gets activated when these flashbacks happen, and that releases cortisol. There is a theory that there is a relationship between this chronic HPA activation that is present in people with PTSD that releases cortisol. So individuals with PTSD having cortisol consistently released in their bodies could be related to this shrunk hippocampus that results in memory issues. So what do we know? What supports this theory? Well, they've done animal studies where they have actually induced high cortisol and chronic HPA activation in animals. And this is what they found. They found that that led to less dendritic branching. What does that mean? It means less growth and a smaller size of neurons in the brain, specifically in the hippocampus. They found less neurogenesis, which is the creation of new neurons. So less neurons were being created to add to the volume of the hippocampus. And they found that the brain was more vulnerable to damage or toxins. So in individuals, or sorry, not individuals, I guess we don't call animals individuals. In animals who had this chronic HPA activation, they were more vulnerable to brain damage. They've also conducted human correlational studies. So we've seen that individuals with PTSD have this altered cortisol, where the HPA axis is being activated and cortisol is being released a lot more than usual. And we've seen that individuals with PTSD have a smaller hippocampal volume. What don't we know, though? Well, we don't know causation. No one has proven causation. They have not proved that this cortisol that is consistently being released in individuals with PTSD is what is causing hippocampal shrinkage. We have not proven that. And there's a confounding factor here that makes everything more complicated, which is that some individuals with PTSD in these studies, these brain imaging studies that found that individuals with PTSD have a smaller hippocampus, some of those participants already had the smaller hippocampus before they were diagnosed with PTSD. So then the question becomes, is a smaller hippocampus actually a risk factor to PTSD and to developing PTSD and to your brain reacting to a traumatic event in a way that leads to PTSD? So maybe this relationship is actually the other way around. These are questions to think about. So that is one theory. Another theory, and this is my specialty and what I did research on for a few years, is that flashbacks are a form of altered consciousness rather than a form of memory. Why do we think this? Well, we know that the phenomenology of flashbacks is more similar to altered perception than a memory. What do I mean by that? There are the criteria that make a memory, and there are the criteria that make altered perception, for example, hallucinations. And we've found that the criteria of flashbacks is more aligned with that of altered perception, like hallucinations, than that of memories. Like I said, we found that flashbacks and trauma memories are fundamentally different than non-traumatic memories. And they're more alike. They're more like altered perception. So this is why we have this theory. We also have found, studies have been done that show that brain regions associated with perception, like the sensory cortices and the amygdala, are activated during flashbacks, which is more in line with altered perception than memory. We also know that there's a temporal component, mental time travel, which is also more in line with altered perception than memories, because like I said, in traditional memories, you know they happened in the past. So it's more like flashbacks are behaving in our brain like there is a real present threat to perceive and not like a memory. But the thing about this theory that both attracts me to this subject and is very frustrating as someone who studies this subject is that altered perception is extremely difficult to study. If you know anything about inducing hallucinations experimentally, you know that it's a pain in the butt. It's really hard to design an experiment where you are inducing hallucinations. And so it's very hard to study altered perception. There's not a whole lot of research about it, and it's hard to get research funding for it. So we don't know a lot about this theory. Most importantly, why this might be happening. If this theory is correct, why? What is the reason? What is going on in the brain that is causing traumatic memories to be consolidated as altered consciousness instead of as memories? We have no idea. Well, there are theories, but we really don't know. We don't have proof. So that's another theory, another thing to think about. And finally, there's the dual representation theory. This one, I think, of the three theories is the one that has the most oomph behind it. It has the most evidence. But again, it's just a theory for right now. So we know that trauma and flashbacks are hard to put into words. We also know that flashbacks are more sensory and overwhelming, like I said, than other memories. So we experience more of the emotion and we experience biological symptoms with flashbacks that we don't experience in normal memory. And we also know that flashbacks are not told as a story or chronologically. They jump around. It's all jumbled up. So this theory proposes that traumatic memories compared to regular memories are mediated by two systems working in parallel, just for trauma memory. And that there's one system that is the narrative system that handles the context and the story. And there's another system, the sensory emotional system, that handles the images and feelings. And they're supposed to work together. But in trauma memory, the emotional system overrides the narrative system. And that's why the narrative gets jumbled up, and things aren't in order, and we have gaps in our memory, and we're very emotional about flashbacks and physiologically activated about flashbacks. So that is what this theory posits. So I just explained a whole lot about the neuroscience of trauma and memory, and a lot of it was left up in the air because there's a lot that we don't know, right? And you might be thinking, well, that's a little depressing for people with PTSD that we don't know. There's a lot we don't know. But there's a lot that we do know that is helpful for individuals with PTSD. Most importantly, the fact that our brains are plastic, neuroplasticity. So our brains are capable of growing, changing, and learning. Your brain is always changing. In fact, your brain is experiencing changes right now. All of us, yes, all of us right now, our brains are experiencing changes as I speak. How does this happen? It happens in so many ways. There are constantly changes happening in our brains. There's neurogenesis, which is the creation of new neurons, and neuronal loss and apoptosis, which is the death of neurons. There's synaptic pruning and synaptogenesis, which is the creation and destruction of connections between neurons. So our brain is always forming connections between different things and destroying those connections and rebuilding them. It's constantly undergoing renovations in your brain. There's dendritic retraction and branching, where your actual brain cells are growing or shrinking or making new connections or destroying them. And there's Hebbian plasticity, which means that cells that fire together wire together. Essentially, that if you do something enough times, your brain will make connections, which means all of this means that our brains can be reprogrammed, essentially, and can recover from mental illness, including PTSD. So PTSD doesn't have to be lifelong. And theoretically, all of those anatomical changes that I've mentioned, so the overactivation of the amygdala, the shrinking of the hippocampus, and the lesser activation of the prefrontal cortex could all theoretically be reversed, and a person could recover from PTSD. We know this because of neuroplasticity. So a little happy note to end off on. And that was the brain behind the behavior, neurocorrelates of traumatic memories. I'd like to open the floor to any questions that you have. I see so many questions in the chat. So I'm going to first open the chat, and if I can figure out how to open the chat, my goodness. Okay, here we go. Let's see, questions. Oh my goodness, there are so many. Okay. Is there a kind of neurotherapy like neurofeedback for PTSD patients? I don't know if you guys have ever heard of EMDR or ART, but they are two types of essentially reprogramming exercises for PTSD. So I mentioned that our brain is plastic and our brains can be reprogrammed. That's essentially what EMDR and ART attempt to do, is they enter your brain into that fight or flight mode by accessing traumatic memories, and then they allow you to change your response. So they intentionally activate flashbacks or activate trauma, and then they work through it with you to try to change your brain's automatic response to that. So yes, there is a type of like neurofeedback therapy for PTSD patients. Let's see. If someone said, and this is a very cool point, if memory lacks context, how do you trust recall? Well, that's exactly why PTSD and PTSD flashbacks can be really, really scary for the person experiencing them, because The person experiencing the flashbacks and who has experienced the traumatic event starts having memories, and they can't tell if the memory is accurate, if it's a correct interpretation of what happened to them. And so they begin to doubt themselves. And there are all these secondary, what we call secondary symptoms of PTSD that arise because the person starts to doubt themselves, doubt their experience, doubt what happened, question if it actually happened, and it can really screw with your brain and screw with your emotions and your interpretation of what happened to you. So yes, that is a really good point. Let's see. Ooh, could you use computational models to replicate altered perception? Technically and theoretically, yes. Computational models of neurons are a whole thing, a really, really popular thing nowadays. Now that we have AI, now that we've made all of these technological developments, they're actually building currently a computational model of the human brain that is complete. They've just done it. I believe they just did it with the fruit fly, the Drosophila melanogaster, which is the fruit fly. They've replicated the entire brain of the fruit fly in a computer so that they can do these kinds of things with a fruit fly brain. However, a fruit fly brain, God, my R's and my L's are getting mixed up, is so much tinier and so much less complex than a human brain. So the human brain obviously is taking a much longer time and way more manpower to create computationally than a fruit fly brain. But yes, theoretically, we could do that. And we can do it on a very, very small level. I think it's been done with certain parts of the brain or handfuls of neurons, if you will, but it can't be done on an entire systemic level the way that we've done it with the fruit fly. Does trauma affect verbal ability? If you mean like your ability to speak generally, like anomia or different speech disorders, I am not so familiar with the relationship between those things. However, we do know that there's a relationship between experiencing trauma or having PTSD and your ability to convey what happened to you verbally. You might be able to understand it in your brain, but it's difficult to convey verbally because that trauma memory gets so jumbled up and we lack the context, and there's issues with recall that I just talked about. So it can be difficult to explain to someone else what happened because the memory in your head is so jumbled up. So in that way, yes, it can affect verbal ability. So now I will open the floor. If anyone has any other questions that they want to just unmute themselves and ask, you can feel free.
Regardless of the context of your lecture, what do you think about biocomputers and their usage right now?
I am not as familiar. So like I said, and you maybe noticed with my lack of comprehension for Google Meet, I'm not a techie person. So I'm not too familiar with biotechnology, but I am familiar with the use of certain AI systems, specifically in neuroscience, and the ways in which we've used AI in neuroscience and medicine. I think it can be a really, really good tool to speed things up and do things that would have taken someone ages to do by hand. For example, when I worked in a memory lab, one of the things that we had to do was score 13,000 pieces of autobiographical memory details that participants gave us in autobiographical interviews. You can imagine that doing that by hand would really, really be not so great, right? That would take forever. And at first we did do it by hand. And then we trained an AI model to do it. And we had people correct any mistakes that the AI model made and go over it and check through what the AI model did. And that very much sped up the process of scientific research. So in that way, AI and computational models can be really, really helpful. Computational models can also be helpful to, like I said, model neurons, like we've modeled the fruit fly. You can model neurons and experimentally induce things that you can't do ethically with actual humans, which is a reason why computers are really helpful. And then in medicine, you can use AI to they've found a lot of success using AI to actually find cancer in individuals before traditional imaging is able to. And that's been really, really useful. There are a lot of developments in that. So in those ways, I think that AI can be really, really helpful. I think there's also a lot to be said for the concerns and limitations of AI. I think we need to have a lot more policies regarding AI and its usage, and we need to really think critically and ethically about what we are using AI for, specifically in the research space and the medical space, because any mistakes that AI might make could directly impact people and cost them their lives. So we need to be very careful about how we're using AI and what we're using it for. But those are a little bit of my thoughts on the matter. Again, I'm not too familiar with biocomputing, because that's not my field.
Yeah, thanks a lot for your answer.
Yeah. All right. Any other last question? Oh, I also meant to mention, so this is being recorded, right, Amarali?
Yes, correct.
Okay. It is being recorded. I will provide to Amarali the slides, which actually have all of the studies that I read for this. Well, not all of them, but the important ones. There are about 500 studies that I've read over the last 6 years or so that are related to this topic, but these are the most pertinent ones, and they are on this last slide. So I will have him, can you send out this presentation to everybody?
Absolutely. I can send it, or I can also add you to the group chat so you can share any resources you'd like to.
Perfect. Yeah. So, okay, I will do that. I will share the slides, which have all of my sources. If you'd like to read the actual studies yourself, these are some of the most pertinent ones. And you can also go through if you missed anything or you'd just like to look through the presentation again, that'll be available. And then I'll also link Research Girl, which is my nonprofit. We have a lot of cool things coming up. We've got workshops for learning how to code, which are completely free to attend. And you can learn how to code in different coding languages and follow along in Google Colab. We've got our mentorship program, which is opening in the summer. We've got 2 mentorship programs, actually. One that's for pursuing independent research projects, and one that is just for assigning you a mentor to help guide you on your career journey in scientific research. So those are 2 great programs that we have coming up this summer that I'm excited about. And then keep an eye out for, in about April or May, we're going to be publishing our very first Research Girl journal, which contains independent research that students from literally around the world, we represent 161 countries, so from around the world, have conducted and that are being published in our journal. So keep a lookout for that. That will be published on our website, and I will send a link to all of that. The website, which has the mentorship program applications and the coding webinar signups and everything, I will send a link out to.
Yes, I'll add you to the group chat so you can send everything.
Excellent.
Perfect. Thank you so much, Mia, for that wonderful presentation. We learned so much from you, and we look forward to having you back at future STEMQuest to present about more topics in neuroscience or really any topic. I know you're knowledgeable across a variety of fields. So thank you so much. It was a pleasure to have you speak for us today, and thank you to everyone who joined and to all the great questions that were asked. And have a great day, everyone, no matter where you are. I don't know if it's morning, night, evening, whatever it is. Have a great rest of your day.
Yeah, thank you guys so much. And maybe I'll see you at the next one.
For sure. Take care, Mia.
Bye.
Bye.